All right, algebra, pretty sure I lied to you because I think I said either on the 12.6 or the 12.7 video, I think on the 12.7 video, like, yay, we're done with chapter 12, awesome, and we're not. Um, there are two more sections in chapter 12, and um, I just completely missed that. So not done with chapter 12. So 12.8, and you may be like, wait, we just did quadratic functions in 12.7. Well, yes, we did. But these are a different form. These are f of x is equal to a times x minus h squared plus k. So you probably are already anticipating what is going to be different about these from before. So obviously we are adding in this piece right there, and that is going to be another translation. So these functions we're going to be translating left and right from our basic x squared function. So in example number 1, we are asked to graph x minus 3 squared. Obviously the a in this case would just be 1. And then we're also asked to graph f of x is equal to x squared. So just like in 12.7, we can compare the two graphs. So I've just gone ahead already in both example 1 and 2 and graphed f of x is equal to x squared because at this point you should be very familiar with how to graph that one. And then let's take a look at, in example 1, what happens when we do x minus 3 squared. So if we put 1 in for x, we get 1 minus 3 is negative 2. Negative 2 squared, we get 4. Okay? If x is 2, 2 minus 3 is negative 1. Negative 1 squared is 1. 3 minus 3 is 0. 0 squared is 0. 4 minus 3 is 1. 1 squared is 1. 5 minus 3, 2, 4. So this looks a little bit more like the numbers that we had when we were graphing x squared, but we were choosing negative 2, negative 1, 0, 1, and 2. Okay, so let's graph this right here. So we have 1, 4, which is right there. Okay, we have 1, 4, and then we also have 2, 1. So let's look at 2, 1. 2, 1 is right there. We have 3, 0. Okay, and then we have 4, 1. What did I? 1, 2. Oh, I see what I did. That shouldn't be there. Sorry. That should be right there. 2, 1 is right there. So X-nay on that one. Okay, and then we have 5, 4. Go ahead. Graph that guy. Looks just like the graph of x squared, except for it is moved over. The vertex is moved from 0, 0 to where is the vertex in this case? The vertex is at 3, 0. Okay, so the vertex of this one is 3, 0. Here's our vertex. Okay, example number 2. H of x is equal to x plus 1 squared. Obviously, a is 1. F of x is equal to x squared. Again, I have x squared already graphed on here, okay? And then if x is negative 3 plus 1 is 2, we get 4. If it's negative 2 plus 1 is negative 1, 1. If x is negative 1 plus 1, we get 0. If x is 0, we get 1. If x is 1, we get 4. Okay, so negative 3, 1, 2, 3. Negative 3, 1, 2, 3. Here is negative 3, 4. Negative 2, 1. Negative 1, 0. Then we get 0, 1. And we get 1, 4. Graph is exactly the same as x squared, except for this time the vertex has moved 1 unit to the left, okay? So our vertex for this one is at negative 1, 0. Okay, so vertex at negative 1, 0 when we add 1, okay? In example number 1, vertex is at 0, 3, or excuse me, 3, 0. And I said 0, negative 1, didn't I? I should have said negative 1, 0 for example number 1. Our vertex for number 2. And our example number 1, our vertex is at 3, 0 when we subtract 3. So that should tell you a little bit about what I'm about to explain to you here, okay? The graphs of f of x is equal to ax squared are translated the absolute value of h units horizontally, that means left or right, when a constant h is subtracted from the variable before the expression is squared. The graph of f of x is equal to a times x minus h slides to the right if h is greater than 0, and to the left if x is less than 0. And we saw that in examples number 1 and 2. F of x is equal to a times x minus h squared plus k is the result of combining both horizontal and vertical translations of f of x is equal to ax squared. Initially finding the x coordinate of the vertex by setting the expression within the parentheses equal to 0 will help you determine which values of x you should use in your table. What does that mean? What we want to do when we are solving these expressions that either are in the form of a times x minus h squared or a times x minus h squared plus or minus a k, when we're doing those, what we want to do is we want to set this expression, that should have an x, this expression right here, we want to figure out what value of x makes that 0. What value of x makes that x minus h in the parentheses 0? That's going to help us determine our vertex, and then it will help us decide what are the other values of x that we need to look at to be able to create a nice graph of a parabola that really gives us a good look at what the function looks like. So we need our values of x, and then our values of y are going to be x minus 2 squared minus 1. Now, set x minus 2 equal to 0. Add 2 to both sides. X is equal to 2. So our vertex, the x coordinate of our vertex is going to be 2, okay? And then 2 minus 2 is 0, okay? 0 minus 1 gives us -1. So the vertex of our parabola, in this case, is going to be 2, -1. All right, 2, -1. Now we want to choose values for x. We want to choose the two values to the left of that x value of our vertex and the two values to the right, okay? So we're going to go ahead, we're going to do 1 and 0, and we're also going to do 3 and 4, okay? So when x is 1, 1 minus 2 is -1. -1 squared is 1. 1 minus 1 is 0, okay? When x is 0, that's 0 minus 2, that's -2. -2 squared is 4. 4 minus 1 is 3. When x is 3, 3 minus 2 is 1. 1 squared is 1. 1 minus 1 is 0. When x is 4, 4 minus 2 is 2. 2 squared is 4. 4 minus 1 is 3. So now, plot your points. So we have 2, -1, 1, 0, 0, 3, 3, 0, and 4, 3. Okay, look. Now we have a nice little parabola. Vertex of our typical x squared parabola would be right here at 0, 0. The vertex of this parabola is at 2, -1. So we have translated 2 units to the right, okay, which, as up above in this first paragraph, we said that the graph will slide to the right if h is greater than 0, okay, and slides to the left if x is less than 0, okay? So we've gone 2 units to the right, and then we've gone 1 unit down. from 0, 0. That's the vertical translation. That's what we were looking at yesterday, okay? So notice the result. Notice what happens, okay? If we take f of x is equal to a times x minus h squared plus k when x is equal to h, okay? So I've just substituted in h for this x right here. So if h is x, we end up with a times 0 squared plus k. F of h is equal to k. Therefore, the vertex of the parabola is hk. The equation for the line of symmetry for this would be x is equal to h. Now, example number 4 says q of x is equal to -2. So now we have a different quantity here for a. All the rest of them that we've looked at have had a 1. Okay, now we have -2. -2 times x minus 3 squared plus 5. There's a lot happening in this function, okay? First thing we want to do is we want to find the vertex, okay? That vertex will help us also be able to figure out the equation for the parabola's line of symmetry, okay? So what we do to find the vertex, remember we take the expression that's within the parentheses, we set that equal to 0, and that gives us the x coordinate. So x minus 3 is equal to 0, add 3 to both sides, x is equal to 3. So that gives us the x coordinate of the vertex as well as the equation for the line of symmetry for this parabola, okay, for the line of symmetry for this parabola. Now, we know our vertex is going to be at 3, and we're going to choose the 2 values to the left of x and the 2 values to the right of that vertex, okay? So 2 and 1, 4 and 5, and solve this to figure out the rest of the points that we are going to go ahead and graph. So we already did 3. We know that when x is 3, well, we didn't already do 3. We know that the x coordinate of the vertex is 3. We don't know the y coordinate yet. So I'm just going to start at the top with 1, okay? So plug in 1, we get, and I'm going to, because this is a longer function, I'm just going to go ahead and write it all out. 1 minus 3 squared plus 5. And let's just go ahead and put this q of x here, which we know also is synonymous with y, okay? So 1 minus 3 in parentheses is -2. -2 squared is 4. 4 times -2 is -8 plus 5, okay? Plus 5 gives us -3. All right? Now, -2 times 2 minus 3 squared plus 5. So 2 minus 3, -1, -1 squared, 1. 1 times -2, -2, -2 plus 5 gives us a positive 3. Plug in 3, and we get 3 minus, whoops, I was already thinking 0. 3 minus 3 squared plus 5. So 3 minus 3 squared is 0. 0 times -2 is 0. So we have 3, 5. And remember, this is our vertex, okay? Then we have 4, -2 times 4 minus 3 squared plus 5. We figured out our vertex, so you should already know what this y value is going to be for x here. Okay, it should be 3. This is our parabola is turning around here. 4 minus 3 is 1. 1 squared is 1. 1 times -2 is -2. -2 plus 5 is 3. So what's going to be our y value for 5? It's -3. Let's just make sure. Okay, 5 minus 3 is 2. 2 squared is 4. 4 times -2 is -8. -8 plus 5 is -3. Now go ahead and graph your points. We have 1, -3. We have 2, 2 and 3. We have 3 and 5. 5. We have 4 and 3. And we have 5 and -3. So now we have a little upside down parabola, and our vertex is at 3, 5. The line of symmetry for this parabola is right here at x is equal to 3. Okay, moving right along. The f of x is equal to a times x minus h squared plus k form of a quadratic function can be called the vertex form or the graphing form because it displays so much information about the graph of a quadratic function. So here we have f of x is equal to negative x squared. When we plug that into the vertex or graphing form, we get f of x is equal to -1, okay, because we have a 1 out here, okay? -1, what is h? There is no h and there is no k in this function, right? So the graphing form is -1 times x minus 0 or squared, and then plus 0 because there is no h, there is no k. Our vertex is at 0, 0, okay? And then our graph opens down, and it opens down because a is less than 0. Comparison of the shape to f of x equals x squared. Okay, this is going back to, I think we talked about shape in 12.7. I just turned my page really quick to make sure that's where we talked about if something was steeper or flatter. Yes, 12.7. Okay, so just back one lesson. The shape of f of x is equal to negative x squared is going to be the same. Okay, it's the same. And the way that we determine that is we look at the absolute value of a. Okay, the absolute value of a in x squared is 1. The absolute value of a in negative x squared is also 1. Because those are the same, the shape is the same. Okay, now look at the next one. F of x is equal to 3x squared minus 4. Put that into graphing form. There is no h, right? There's no h here, okay? But there is a k. There's a -4. So when we put that into graphing form, we have f of x is equal to 3. 3 is a, so here's 3, times x minus 0, because there is no h. X minus 0 squared minus 4, that's outside of the parentheses. So our vertex is at 0, -4. Our graph is going to open up because a is greater than 0. A is positive. It's greater than 0. So our parabola opens up, and it is steeper than the graph of x squared because the absolute value of a, which is 3, is greater than 1. So that makes a steeper parabola, okay, or parabolic function, okay? F of x is equal to x plus 1 squared, okay? So a in this case is 1 and k is 0. There's nothing over here, right? So that's just 0. So when we put that in vertex or graphing form, that's f of x is equal to 1, there's a, times x, and we write x minus 1 because this is the standard form, x minus h. So x minus 1 is the same as adding 1. Remember, subtraction is adding the opposite. So x minus 1 is the same as this plus 1 right here. That's squared, and we have plus 0 because there is no k. Our vertex is at -1, 0. Our graph opens up because a is greater than 1. And the absolute value of this function, or of a, is 1. So the shape of f of x is equal to x plus 1 squared is going to be the same as the shape of x squared. And we saw that back in example number 1 and number 2, where a was 1 in both of those. It was the same shape as our basic parabola. Last two, x minus 2 squared minus 1. So a again is 1. 1 comes out here in our graphing function. X minus 2 squared minus 1 is k. So our vertex is at 2, -1. This is going to open up because a is 1. It's greater than 0. Same shape as x squared because the absolute value of a is 1. Last one, -1/3 times x plus 7 squared plus 9. So we have an opposite of h, okay? We have a at -1/3, and we have k out here. So f of x is equal to -1/3, and here we have this x minus -7. Subtraction is adding the opposite, so x minus -7 is the same as adding this 7 here. So 1/3 x minus -7 squared plus k is 9. Our vertex is at -7, 9. The graph is going to open down. Why is it going to open down? Because -1/3 is less than 0. So this graph opens down, and it is flatter than x squared because the absolute value of a is less than 1. The absolute value of a is 1/3. In this case, 1/3 is smaller than 1, so it's going to be a flatter parabola. If a quadratic function is in standard form, f of x is equal to ax squared plus bx plus c, you can change it to the equivalent vertex form. F of x is equal to a times x minus h squared plus k, using a variation of the procedure outlined in 12.3 for completing the square. Okay, so example number 5 says write f of x is equal to x squared minus 6x plus 10 in graphing form. Okay, in graphing form. Identify the vertex and the direction of the opening. Okay, so just going to write that function here. F of x is equal to x squared minus 6x plus 10. And remember, I just said we're going to use a variation of the procedure outlined in 12.3 for completing the square. Okay, so follow along. Step number 1 is we group the ax squared plus the bx terms. So that gives me f of x is equal to x squared minus 6x plus 10. We are grouping the ax squared plus bx terms, okay? Step number 2 is to complete the square, okay? So what's b in this case? B is -6, okay? So -6 over 2 squared is 9, okay? So we get f of x is equal to x squared minus 6x plus 9 plus 10, and we subtract 9 outside of the parentheses so that the value of the right side of the equation will not change, okay? Step number 3 is we factor the trinomial that we've just made a perfect square trinomial inside the parentheses, right? F of x is equal to x minus 3 squared. And what do we have out here? Okay, this is x minus 3 squared. That's factoring that perfect square trinomial. And then we have plus 10 minus 9 plus 1. Now we have this in graphing form. Okay, we have it in graphing form, x minus 3 squared plus 1. Okay, so a is 1. Okay, h is 3, and k is 1. So my vertex is at 3, 1, because the vertex is always at h, k. And this graph is going to open up or down. It's going to open up because a is greater than 0, because a is 1. 1 is greater than 0. And this is going to have the same shape as f of x is equal to x squared y, because the absolute value of a is equal to 1. Okay, so vertex up, same shape. Okay, that's how, oh yeah, vertex up, same shape. Okay, moving right along, we will use this formula for h, but it is typically easier to find the value for k by substituting the value of h into f of x. So, why do I have that written there? Oh, I'm sorry, I skipped ahead. If the function, so this is right underneath example number 5 as you're following along in your book on page 518, because I know you all are, if the function has a leading coefficient other than 1, okay, completing the square is more complicated. By completing the square on f of x is equal to ax squared plus bx plus c, we can develop formulas for h and k. All right, so here we have f of x is equal to ax squared plus bx plus c. Group the terms. okay, which I've grouped those, okay? So group the terms and then factor out the leading coefficient a. So we're going to factor out this a. This is assuming a is not 1. So when we factor out a here, we get x squared plus b over a, because b over a times a would give me just b, times x plus c. Now, complete the square by adding, remember we complete the square by adding 1/2 times b, so that would be 1/2 times b over a squared, which would be b over 2a squared, which is b squared over 4a squared, okay? So complete the square by adding b squared over 4a squared inside the parentheses, right? So we have a times x squared plus ba over x plus b squared over 4a squared plus c, and then remember we subtract the value b squared over 4a squared. We subtract that value outside of the parentheses. That would, in essence, keep both sides of our equation balanced, okay? Now, factor the trinomial. This is a perfect square trinomial right here. A still stays out here. When we factor x squared plus b over ax plus b squared over 4a squared, we get x plus b over 2a squared plus this whole mess over here, c minus b squared over 4a. All right, so in this case, h is equal to b over 2a, h is equal to negative b over 2a, and k is equal to this whole thing. Okay, so k is equal to c minus b squared over 4a. Some of you are probably struggling with why this is negative, why h is negative, because our formula is f of x is equal to a times x minus h squared plus k, right? So x minus negative h, okay? Or excuse me, gives us x plus h, right? X plus h, which is what we have here. So we have them opposite here. Okay, so h is negative b over 2a, k is c minus b squared over 4a. Now, I can say what I just said. We will use this formula for h, but it is typically easier to find the value for k by substituting the value of h into f of x. Now, okay, now we're going to use what we just learned, particularly in solving for h, to work through example number 6. Example number 6 says state the vertex of f of x is equal to, sorry, and I erased some of that, negative 2x squared minus 12x minus 19. Okay, remember vertex is h, k. All right, so we're going to use our formula for h, where h is equal to negative b over 2a to figure out what h is. So if h is equal to negative b over 2a, in our formula, or in our function, negative 2x squared minus 12x minus 19, b is negative 12. So negative, because we have negative b over 2a, negative 12, because b is negative 12, over 2 times a is negative 2. So that is negative 12 over negative 4. Negative 12 divided by negative 4 is positive 3. So h is negative 3. Now, instead of using k is equal to c minus b squared over 4a, which you could do to find k, we are actually just going to plug this value for h, okay, negative 3, into our function and figure out what k is. And we can do that because we know by definition k is equal to the function of h. All right, so go ahead and plug in negative 3 for x. When x is negative 3, and we know that that's the x coordinate at the vertex, so negative 2 times negative 3 squared minus 12 times negative 3 minus 19, okay? Negative 3 squared is 9. 9 times negative 2 gives us negative 18 minus negative 36 minus 19. That's negative 18 plus 36. Negative 18 plus 36 is positive 18 minus 19 is negative 1. That's K. So our vertex is at negative 3, negative 1. Now we are asked to plot this graph. So when x is negative 3, we know we have negative 1. What about when x is negative 2? Okay, when x is negative 2, negative 2 times negative 2 squared minus 12 times negative 2 minus 19. Okay, so that's negative 2 times 4. Okay, negative 2 times 4 is 8 minus negative 24. So that's negative 8 plus 24 minus 19. Negative 8 plus 24 minus 19 gives us negative 3. And let's just do this. All right, so we get f of x or y. What about when x is negative 1? Negative 2 times negative 1 squared minus 12 times negative 1 minus 19. So that's negative 2 minus negative 12 minus 19. So negative 2 plus 12 minus 19 gives us negative 9. So let's graph these 3 points. We know negative 3, negative 1 is our vertex. So that is the turning point of our parabola. We also know that this parabola, what direction will this parabola be opening? It will be opening down. How do I know that? Because A is negative. If A is negative, the parabola opens down. So negative 3, 1, 2, 3, negative 1, negative 2, and negative 3. So negative 3, negative 1, negative 2, 1, 2, 3, negative 1, and negative 1, negative 9 down here. Now, without me plugging in anything else for x, okay, look at this parabola and determine what are 2 more points that I can super easily graph on here. What can I super easily graph? Okay, hopefully you are seeing at this point, we want to graph negative 4. And without plugging in negative 4 into this long function and solving for it, think in your heads, what is going to be the corresponding y value for negative 4? If this is a parabola and this is one side of the parabola, this is the vertex, so this is where it's turning. It's also its line of symmetry, okay? Then we know that negative 4 is the mirror image of this point right here. Negative 4, negative 3, okay? We also then know that negative 5 is going to be the mirror image of this point down here. So we're going to have negative 5, negative 9, because we've turned at negative 3, negative 1. And there's the rest of our parabola, and I didn't have to figure out any more values, okay? There you go. Sorry, this lesson was really long.